Hey everyone, it's Roy. Okay, seems we're fine. Okay, so yesterday I fixed a lot of stuff in my Vim installation. So now I actually also do have Copilot enabled again. It was only a problem with Node.js version, which with Pop OS it's 12 point something, but the plugin wanted 14 point something. That's at least how I understood it. So I did that. I've also removed some stuff from it that I don't need. So there's a integrated debugger in Lunar Vim, but I'm not gonna use it like that. I've fixed some of my I've also done some of other configuration. I forgot what I did. Let's see. So yeah, I added a few. I've changed the theme obviously, so now it's Cat Puccin, which is a nice theme. I also I hate italics in code, so I instructed it explicitly not to use italics. I think it still has italics in some places, like variable names, argument names, and so on. But I'll get to that sooner or later. It irritates me, so I will remove it. And yeah, this is my small configuration. So I do have some of these themes. I installed some of these themes which I tried, but in the end I ended up with Cappuccino, which is a very nice theme. And I have Copilot finally installed back. So that's a nice touch. Today we will do development of our game. Finally work on the game, not the build system. So last time what we did was we've created build scripts and we've converted everything to CMake. We switched to Linux. There's a lot of things that I did last time, but now I have some scripts, and I also added support for specifying the target to the build script. So it's in the .scripts folder, build, debug, and I can specify target now. So my target is Pacman. That's it. So there's obviously nothing to do because it's already built. And if we run this game, that's in build, debug games, Pacman. Right, we get this few rectangles that we're drawing and yellow rectangle that we can move around the screen by pressing arrow keys, right? And there's also an option to do some sound. So that's all fine, but I've noticed that there's a problem. So basically what happens is if we would go into, I believe it's in the geographics, right? This file here, where we initialize the graphics. If we specify the OpenGL to call the back faces, just here for test. So GL enable, GL call face. We will get following problem. There's nothing seen anymore. There's nothing visible anymore. So why this happens? It's most likely because of how I did my projection matrix. So if we go back to our Pacman, our main file, right? And we go to calculate. Here we are. I've inverted the screen height, and so the top and bottom sides I've inverted in the projection matrix, so I can get basically, you know, top to bottom epsilon coordinate, which means that as if epsilon is larger, then the thing is drawn to the bottom of the screen, right? Your normal OpenGL behavior is from bottom to top, right? So as it is in mathematics. And the problem is basically here. So if I simply move this, right? And I think it's just what is happening. I'm obviously very tired today. Okay, and if we build it now and run it, we will now again see our quads, rectangles that we draw, but this time they'll be drawn from bottom to up, which is what the OpenGL wants. And this is, I want to investigate. I know why it's happening, and I know how to fix it, but I want to get better understanding of the problem from mathematical perspective, right? So if we go to definition, which is in here, we can see how the matrix was built. So it looks like, yeah, first column is this, second column, this is the second column, and this is the third column, and this is the fourth column. If I'm not mistaken, this is actually how how we should do it in OpenGL with GL ortho function. Right, let's see. Yeah, 2 over right minus left, 2 over top minus bottom, minus 2 over d far minus d near. So these are d far and d near are distances, not coordinates. And then we have dx, dy, and dz. So dx is minus right plus left cross right minus left. That's fine. The epsilon is minus top plus bottom cross top over top minus bottom. That's fine. Dz is minus far wall plus near wall over near far wall minus near wall. And yeah, that looks okay. So the code is correct here. Let's just check. So first column is laid out as first 4 values in the matrix. That's fine. Second column is this one. That's fine. There's no typos or anything. Just checking for that. Yeah, everything seems fine, right? So let's visualize the problem, what's happening. OpenGL NDC space, that's important to know. This is space. It's from -1 to +1. Let's see what's on Hoi space going. Yeah, -1 to +1. Yeah. Okay, let's do some drawing. Let's figure this out. Where's my office? Ops is here, and let me switch to this screen. So We have a projection matrix. Let's do that in blue color. And our projection matrix, ortho projection matrix, which has elements A, B, C, D, E, F, G, H, I, J, K, L, M, P, and the elements like you've seen in the screen. And we have some kind of point, right? So game screen. So that's the point, and it needs to be in 4 coordinates, in 4 dimensions, but we will just specify x and y. So this is what the projection matrix. So this is kind of a projection matrix, right? Projection matrix, and this is some kind of vertex, basically. Vertex position. It can be other things, I guess, but in this case we're talking about 2D, right? Vertex position. And the job of the projection matrix is to take so-called, let's do color, so-called view space. I'm gonna call game view space, which in my case is just something, which is like something like 4/3. Let's do it correctly then. If I'm gonna talk about 4/3, then let's do it 4/3. Something like this, right? And so it's basically your viewport or whatever, but it's not viewport actually, but it is something that we define, a size that we define by projection matrix, basically. So in my case, it's 0. So it's 0 on x, so this is x-axis, right? 320 here, and on y it's 240, right? So this is x-axis, and this here is y-axis. So that's my view space, how we have it now, but that's just an example of view space. I'll get back to this. But we want to convert that into the so-called DC space. Which is, let me see if I'm getting the dimensions right? So 3 by 3 into 3, which is from -1 plus 1 plus 1, right? So the job of the projection matrix, here it is. Let's use the colors. Did it in blue, projection matrix. Just call it projection, converts, from this space to that space. And to be more clear, this is not 320. It can be anything specified by the viewport function, right? So it can be, I just want to confuse that with our configuration. So it can be basically some width and height, right? Okay. And the problem, the thing that I did here is that I defined my projection with inverted height, basically. So the projection function, which is also kind of a standard in OpenGL, it takes 4 parameters. It takes left, it takes right, it takes bottom, and top, right, and D near, D far. So that's the parameters it takes. So when you think about it in view space, the left and right are here, right? So this is x coordinate, so this is L, this is right, and the bottom and top are here, and I'm not gonna talk about D near and D far. They are important, but not for this context, right? And what basically happens is that the OpenGL we usually expect, right? So it's expected that the bottom is smaller than top, right? So it go because OpenGL wants to go from negative to positive direction, but that means that I need to specify all my game space coordinates. But the standard in doing 2D games is, instead of going from bottom to up, the standard is from top to bottom. That's standard. So it's in positive direction. So that's why I simply, invert these things. I actually have bottom larger than top because in my system the bottom is what was it? It's 300 and the bottom is 320, right? And the top is 0. So that means if I specify something, on the coordinate 200, it's gonna be somewhere here. That's in my space 200 is somewhere here, so it's gonna be somewhere here, let's say like that. While in other space it would be somewhere here, right? But we want this space, right? So we want to have top to bottom. That's what we want. And the bad thing that happens here is that because I flipped this epsilon coordinate, I think what's happening is that let's go to another page. So normally, right? Normally, we specify in OpenGL. You always specify. You want to specify the triangle in counterclockwise order. So that means basically that, let's say we have a triangle with point A, right? And then it's going to let's put this one on -1. I'm talking now in normalized coordinates, but before projection. In -1 and it's 1, right? And then we have some kind of B down there, which is -1, and then we have a C point, right? Which is then 1, -1. And that's my counterclockwise triangle. Let's do it like this. So first edge is this, second edge is this, and the third edge is this, right? First, second, third. So that's my counterclockwise triangle. But now if I go to projection with inverted projection where both top is -1, bottom is 1 plus 1, right? So that means that it flips y, and if I pass this triangle through that, what will happen? This is what I believe happens, right? Is that in NDC space, we will have point B here and point C here, and then 2, 3.5 point A there, and the edges are still going in the same direction from A to B, from B to C, and from C to B, but in NDC space, this is now counterclockwise. So, and that's bad, right? So, workspace here. Yeah. This is NDC space. Right. Okay. And I want to today just figure if this is why it's happening, and then if I'm correct, if the mathematics is correct, we can figure out if how to solve this problem. What will be the best way? I mean, I know how to immediately solve it. We can just switch here. That's my GL graphics. We can just say currently GL front face will be GL clockwise, right? So instead of counterclockwise, which is the default for front faces, we can just specify to OpenGL that we want clockwise space, and that will solve our problem. Or won't it not? Or will it not? Sorry. Front face is clockwise. What did I do now? I said this to counterclockwise. Yeah, that's because I've changed the matrix already, Jesus. So if I go back with the matrix, right? Jump to here. Right, if I do it like this, so I've converted it back to inverted matrix, and you know, I've only set it up now so that the face is clockwise, front face, so that OpenGL treats the clockwise faces as the one that will not get called. So that works then, right? Is this enough? Should I just do that? But I'm thinking what's gonna happen with texture coordinates, right? So the textures will get inverted as well, right? Because we'll get flipped on it. So and I don't want that. Let's go back to tablets. So if I have a rectangle, so that's I'm drawing some kind of rectangle on screen, right? And this will be composed of two triangles. And rectangle is important because with rectangle we're gonna draw our sprites. So composed of two triangles, and the directions points are something like this, right? So this is A, B, C, and D, and we have two triangles here. So green color, and we have triangle 1 and triangle 2, and triangle 1 is from A to B to and from C, A, B, C, A, that's triangle 1, right? And triangle 2 can be, let's use another color, from A to C, C to D, and D to A. Right. So first one is A, B, C, and second one is A, C, D. I just want to explain how what is drawn. But with each triangle we have our position and we have our texture coordinates. So for A, I'm gonna say that position PA is, so this is still specified as you will usually specify in OpenGL, but probably before we did projection, right? So PA is -1 + 1, and texture coordinate for A is, since this is top left, it's gonna be 0, 1, right? And PB is it's -1 on X and -1 on Y, and TB texture coordinate, this is bottom left, so it's 0, 0. PC is 1, -1, and TC is so it's bottom right, 1, 0. And PD is 1, 1, and TD is also 1, 1. Now if I go to our projection matrix P, okay, go that to somewhere down there, and this will be the color for flipped one. Let's do this. I'm trying to make it a product. It doesn't matter really. It's just approximation, right? So we have A transformed, B transformed, C transformed, and D transformed. And we're transforming only positions, right? So PA transformed is gonna be, we flip the coordinate on epsilon, so that one is -1. Yeah, sorry, I can't annotate a minute. We don't have, so we just want to calculate first, right? How about it this way, then we can draw, and that's gonna be this one, right? And PB is -1, 1, that's this one, right? And then we have PC transformed is 1 - 1 + 1, so we transform it, so that's C, and PT transformed is 1 - 1. 1, yeah, so that's it. So that's the transform. Okay. But you know, texture coordinates still stay the same. So for TA transformed, it's still 0, 1. For TP transformed, it's still 0, 0. For TC transformed, it's definitely still 1, 0. And from TD transformed, it is 1, 1. So imagine now if we had a texture, let's do some primitive drawing, right? So our texture is just this is our texture, so it's 1 pixel red, then pixel green, pixel blue, 1 pixel yellow, right? And the texture mapping to this quad, right, is virtually gonna be something like, literally gonna be something like this. Gonna split it in 4 quads. So the red is gonna be here, right? That's our red pixel. Can I do this soft? Right, and the green pixel is gonna be here. And blue pixel is gonna be here. And yellow pixel is here. Okay, that's how it's transformed. It's applied onto quad. The texture how is applied onto quad like this. But since now in here it will basically be inverse on epsilon axis. So again, I'll divide this. Trying to divide it into 4 equal, okay. Doesn't really matter, but for the point. So this one is gonna be inverted topics, yeah, and that's not what I want. Hello? Okay, dobra. Okay. That's not what I want, right? I want to have them in the OpenGL order, so. Okay. So basically, I think our only solution, since I want to have I'm thinking, yeah, I think that was the solution is to just specify the original coordinates with inverted epsilon. We will always need to think in that terms, but the textures will get mapped properly. Let's test this out. So yeah, that's it. Yeah, I think that's it. So let's return this back as it was before. Okay, and where do I need to go? So not math. It's the check graphics thing, right? Remove the front face calling. I mean, enable the calling, but make it front. don't change the color order. And so basically we should be able to build it, and we should not see anything now. That's what I'm expecting. We don't see anything, that's correct. And if I go now into geographics, which is here, I can trick the system by multiplying. I can, okay, I can do it in two ways, right? So I can, where do I spray? I can invert the epsilon coordinate at the place where I specify my vertices, right? So this is, and it's actually, yeah, I think that's actually the best idea. So what I was thinking is I can do it here. And if I switch my thinking into the what is NDC now, right? So into my game space, right? If you're negative on epsilon direction, you're more up. So yeah, it actually makes sense with to make the top left kind of be -1 because this is what the B top left. Yeah, that would then convert it to be actual top left in NDC space. Right, so let's do it like that. So this is changed. Changed -1. So we just need to, I only need to always be careful about how I do my coordinates, because I'm really used to OpenGL system, right, where epsilon direction is up, but now positive epsilon goes down, right? Probably gonna, so top left is negative, bottom is positive, top negative, top negative. That will just work, that will simply work, yeah. Let's write a note here. Note inverted epsilon let's switch coordinates because in our game positive epsilon is down. Very nice. Okay. That should now immediately work. Let's see. It does. And we should not have problems with texture mapping. So the bottom left pixel will be at bottom left corner. That's the goal. Okay, this was nice and short, but very important. Very important. Let's just this one. No, what's the problem with this kind of edges. They have too many options. And then I always get lost in those options. And I'm not actually very used to Vim, right? It's a new editor for me. So I need to frequently take a look, down the keyboard to see which button I'm gonna press. Fix calling, fix negative, fix ipson axis. I'm just gonna say that right. And let's push that to master. Push. Okay, let's see one more time. GL enable cow face. Note back faces. Called by default. Look. By default. By default. Okay. I already pushed to master, didn't I? Nah, never mind. It's my project. I can do whatever I want. Add comment, just that. I don't need to type anything. I have this habit to typing push origin master, but if I'm on branch, I can just type push. Ooh. What's wrong? Computer. Yeah. This very rarely happens. Okay, that's it for this stream. Next time I'm gonna render some textures. Bye bye.